Some materials can be magnetized while some cannot. What are the factors that determine the magnetic property of a material? The factors that determine the magnetic property of a material are 1. The configuration of the electrons in the material. 2. The ability of the atoms or molecules in the material to align magnetically. And 3. The alignment of domains or sections in the object. Electron orientation factors. Electrons can behave as tiny magnets, each with north, N, and south, S, poles. When an atom's electrons are lined up in the same orientation, with most having their north pole facing one direction, the atom becomes like a magnet, with north and south poles. It is also possible for the electrons to be in various directions, making the atom non-magnetic. When electrons move, they create a magnetic field. A magnetic field is also created when electrons rotate around a nucleus and when they spin while in orbit. Electrons have a property called spin. This spinning creates a magnetic field with north and south poles, just as the spinning Earth has magnetic poles. If electrons and the shells of an atom spin in the same direction, the atom will exhibit a magnetic field and will respond to the forces of a magnet. If half of the electrons spin one way and the rest spin the other way, they will neutralize each other, and the material will not be affected by a magnetic field. Atoms such as iron have most of their electrons aligned in the same direction. Thus, iron or nickel would be attracted to a magnet. Aluminium only has a few electrons aligned, and thus it is only weakly magnetic. An element with half of its electrons oriented one way would not be attracted to a magnet. Atom or molecule factors. If two or more elements are chemically combined to form a molecule, it is quite possible that the compound is not magnetically inclined, because the orientations of the atoms in the molecule work against each other. A good example of this is to compare the magnetic properties of iron and its compounds iron oxide, rust, and iron sulfide. A piece of iron is highly magnetic, but a hunk of rusty iron is not. Domain or section factors. A group of atoms normally called domain or section may become aligned, but groups of atoms may be misaligned. It is necessary to line up many of the domains in a material like iron in order for it to become a magnet. Alignment of electrons, atoms, and domains are important in determining the magnetic response of a material and whether it is a magnet. Since the atoms or molecules need to be aligned, gases and liquids are typically non-magnetic, and most magnets are solid metals. An exception is in the rotation of liquid iron core of the Earth and the rotating plasmas of the Sun.